Ellipses. In this chapter, we will explore a set of shapes defined by a common characteristic. They can all be formed by slicing a cone with a plane. These families of curves have a broad range of applications in physics and astronomy, from describing the shape of your car headlight reflectors to describing the orbits of planets and comets. The National Statuary Hall in Washington, D.C. is an oval-shaped room called a whispering chamber because the shape makes it possible for sound to reflect from the walls in a special way. Two people standing in specific places are able to hear each other whispering even though they are far apart. To determine where they should stand, we will need to better understand ellipses. An ellipse is a type of conic section, a shape resulting from intersecting a plane with a cone and looking at the curve where they intersect. They were discovered by the Greek mathematician Menachmus over 2 millennia ago. The figure below shows two types of conic sections. When a plane is perpendicular to the axis of the cone, the shape of the intersection is a circle. A slightly tilted plane creates an oval-shaped conic section called an ellipse. An ellipse can be drawn by placing two thumbtacks in a piece of cardboard, then cutting a piece of string longer than the distance between the thumbtacks. Tack each end of the string to the cardboard and trace a curve with a pencil held taut against the string. An ellipse is a set of all points where the sum of the distances from two fixed points is constant. The length of the string is the constant, and the two thumbtacks are fixed points called foci. Ellipse definition and vocabulary. An ellipse is the set of all points Q, x, y, for which the sum of the distance to two fixed points, F1, x1, y1, and F2, x2, y2, called the foci, plural of focus, is a constant K. D, Q, F1 plus D, Q, F2 equals K. The major axis is the line passing through the foci. Vertices are the points on the ellipse which intersect the major axis. The major axis length is the length of the line segment between the vertices. The center is the midpoint between the vertices or the midpoint between the foci. The minor axis is the line perpendicular to the minor axis passing through the center. Minor axis endpoints are the points on the ellipse which intersect the minor axis. The minor axis endpoints are also sometimes called co-vertices. The minor axis length is the length of the line segment between minor axis endpoints. Note that which axis is major and which is minor will depend on the orientation of the ellipse. In the ellipse shown at the right, the foci lie on the y-axis, so that is the major axis, and the x-axis is the minor axis. Because of this, the vertices are the endpoints of the ellipse on the y-axis, and the minor axis endpoints, co-vertices, are the endpoints on the x-axis. Ellipses centered at the origin. From the definition above, we can find an equation for an ellipse. We will find it for an ellipse centered at the origin C, 0, 0, with foci at F1, C, 0, and F2, negative C, 0, where C is greater than 0. Suppose Q, x, y is some point on the ellipse. The distance from F1 to Q is D, Q, F1 equals the square root of x minus c squared plus y minus 0 squared equals the square root of x minus c squared plus y squared. Likewise, the distance from F2 to Q is D, Q, F2 equals the square root of x minus negative c squared plus y minus 0 squared equals the square root of x plus c squared plus y squared. From the definition of the ellipse, the sum of these distances should be constant. D, Q, F1 plus D, Q, F2 equals K, so that the square root of x minus c squared plus y squared plus the square root of x plus c squared plus y squared equals K. If we label one of the vertices a 0, it should satisfy the equation above since it is a point on the ellipse. This allows us to write k in terms of a. The square root of a minus c squared plus 0 squared plus the square root of a plus c squared plus 0 squared equals k. The absolute value of a minus c plus the absolute value of a plus c equals k. Since a greater than 0, these will be positive. A minus c plus a plus c equals k. 2a equals k. Substituting that into our equation, we will now try to rewrite the equation in a friendlier form. Square root of x minus c squared plus y squared plus the square root of x plus c squared plus y squared equals 2a. Move one radical. The square root of x minus c squared plus y squared equals 2a minus the square root of x plus c squared plus y squared. Square both sides. The square root of x minus c squared plus y squared squared equals 2a minus the square root of x plus c squared plus y squared squared. Expand. X minus c squared plus y squared equals 4a squared minus 4a multiplied by the square root of x plus c squared plus y squared plus x plus c squared plus y squared. Expand more. X squared minus 2xc plus c squared plus y squared equals 4a squared minus 4a multiplied by the square root of x plus c squared plus y squared plus x squared plus 2xc plus c squared plus y squared. Combining like terms and isolating the radical leaves 4a multiplied by the square root of x plus c squared plus y squared equals 4a squared plus 4xc. Divide by 4. A multiplied by the square root of x plus c squared plus y squared equals a squared plus xc. Square both sides again. A squared multiplied by x plus c squared plus y squared equals a to the 4th power plus 2a squared xc plus x squared plus c squared. Expand. A squared multiplied by x squared plus 2xc plus c squared plus y squared equals a to the 4th power plus 2a squared xc plus x squared c squared. Distribute. A squared x squared plus 2a squared xc plus a squared c squared plus a squared y squared equals a to the 4th power plus 2a squared xc plus x squared c squared. Combine like terms. A squared x squared minus x squared c squared plus a squared y squared equals a to the 4th power minus a squared c squared. Factor common terms. A squared minus c squared multiplied by x squared plus a squared y squared equals a squared multiplied by a squared minus c squared. Let b squared equal a squared minus c squared. Since a greater than c, we know b greater than 0. Substituting b squared for a squared minus c squared leaves b squared x squared plus a squared y squared equals a squared b squared. Divide both sides by a squared b squared. X squared divided by a squared plus y squared divided by b squared equals 1. This is the standard equation for an ellipse. We typically swap a and b when the major axis of the ellipse is vertical. Equation of an ellipse centered at the origin in standard form. The standard form of an equation of an ellipse centered at the origin c, 0, 0, depends on whether the major axis is horizontal or vertical. The table below gives the standard equation, vertices, minor axis endpoints, foci, and graph for each.